Hello, folks. Welcome to Rational Science, the only site on the internet that does physics rationally. We don't do it right, we do it rationally. And there's a difference. Right means opinion, whereas rationally we define. So if you meet the definition of rationally, then you have a rational theory. Those people who don't like our definition have a single recourse, and that is to define the word rational. Okay, we're going to be doing number line today. We did number the other day. We're going to do number line today. But let's begin with our extinction segment. And here we were talking about the alphabet people the other day. People had some questions about that or some comments. So let's start with those. Here we have a fellow says, I don't think it's genetic, meaning, whether transsexuals and all this stuff that we're seeing today, whether it's got to do with genes, right? Which is our argument here. It's socially engineered from the top down. Uh-huh. And so he talks about the current social engineering, the rich people, I guess, politicians, whoever up there that's running the show. The West is run by hostile elites, okay? Then he says something which is of interest to me, at least. 3 decades ago, these things didn't exist. And that's not enough time for such a radical evolutionary change to occur. And we're going to challenge that. Okay, let's go with the next fellow. And he says the following. He says, I came here for physics, not for LGBT stuff. Come on, Bill. Need to guard children from them. Why do we need to guard children from them? Is it contagious or what? Or do you think this is an issue of education? And if you do, well, we're going to challenge that as well. Okay. And then another fellow says, related to that, he says, all problems we have on Earth come from human overpopulation. The solution is not more babies, because we're saying that the expansion of the human race, the growth rate, population growth rate, is slowing down. And I guess this fellow says, hey, that's a good sign. We're overpopulated as it is, and because we're overpopulated, that's why we're having a lot of these problems. Okay. Well, we're going to challenge all of these gentlemen here. Okay, they have their say, and we're going to challenge that. So let's go with the first one, and that's that the global population has increased at a very small rate over the last thousands of years, really. And it was just in the 19th century, going into the 20th century, that's when population really exploded. We were only about 1 billion people in 1820, and that, you'll get different values for different analysts, but that's a more or less good number to consider. 1 billion, 1820, thereabouts. That's for the whole planet. Today we're 8 times as many. We're 8 billion people, and we come pretty much from those ancestors. Okay, and the issue is, are we going to continue growing exponentially? The answer is no, and then there's only three possibilities. We either go up, continue to expand, we go more or less, maintain a global population around, I don't know, 8 or 9 billion, or we go to extinction. And guess what we propose here? We're saying that we're going down to extinction. And it's got really little to do with population, in the sense that it's not that the growth of population is going to slow down and then we're just going to whittle down to zero. No, no. It's going to be an exponential drop. We're all going to die almost simultaneously. Okay, so it's not a gradual decline. That's what we're going to argue here. If it were a background extinction, it would. We say that humans will die in a mass extinction. We die all of a sudden. Okay, so, and there's nothing we can do about it. And it's guaranteed. It's not that say, well, maybe. No, no, it's guaranteed. Okay, that's what we propose here. Okay, I'm just going to show a fellow who talked about genetic diversity. We say that We have lost our genetic diversity over the centuries, and a lot of people have problems with that. They think that any species, whether plant or animal, gains genetic diversity because we have new mutations every day. That's their notion. That's what I guess that's the worldly wisdom. And we're saying that's absolutely not true. At least that's not what we vouch for here. We say something different. We say that we can only lose, a species can only lose genetic diversity. It has no way of gaining genetic diversity. By that I mean the whole pool. Okay, I don't mean just one or two individuals. I'm saying the whole population. As a whole, it can only lose genetic diversity. And I have a graph that's in one of my books, okay? And it looks more or less like that. You can see that the species can only lose genetic diversity, especially when it becomes sedentary. It no longer migrates, and we are not migrating people anymore. That age has long gone, okay? It's a steady decline, and it's got to do with a couple factors. One of them is the founder's effect, and the other one is population bottlenecks. Okay, so I'm not going to go into detail there, but all we say here is that we can only lose genetic diversity. Okay, and because of that, yeah, this fellow says, well, can that happen in 30 years that because of our loss of genetic diversity, there are such major changes that we see all around us? Okay, and I think there's two factors there, and one is that we have more information today, and a lot of people have come out of the closet. So those are two factors that influence that. But I just want to address essentially these three fellows with Calhoun's experiments. Okay, and that's John Calhoun ran experiments from what is it, 1948 to 1975. Number 25, universe. What is it? Utopian Universe. Number 25 was his, I guess, masterpiece. You could say, his main experiment. He put four mice. I'm sorry, four pairs of mice, male and females. Normal mice, you would say, but remember, it took them out of the existing stocks. It's not like he went out hunting, in the wild for mice. No, he just said, "Give me four pairs of mice," and then he gave him four pairs of mice. That's what he started out with. And there we have our perfect problem, because those mice were already, we'd have to look at their genetics. And I don't think he did that. He was a psychologist, he was studying behavior, okay? And the main thing I got out of his experiments, he's the first guy. I've seen a couple other experiments, but I will concede to him being the first guy to produce homosexuality in the lab. Okay, he produced it with animals. He did not produce it with the people who are on top of us, who impose governments on us. None of that, elites and so on. It's got nothing at all to do with that. Okay, it's got to do with genetics, with biology. Okay, and it's got to do with two things. First, the fact that they started out with this founder's effect, four pairs of mice. Okay, they were normal in general. Male got a female and made his nest, and the other guys did the same thing. So you have four houses. Essentially, that's the starting point. And from there, they ended up with 2,200 mice after several generations. And towards the end of that process, and he did this again, he did this experiment many times, at least 25 times, and he ended up with homosexuals and autists. Okay, the mice, as he said, had stopped being mice. Okay, and this is what his experiment looks like. Okay, he had this, I guess it was like a 9 square feet space, and he just allowed the mice to do anything they wanted. They had all the food they wanted. They had all the water they wanted. They had no predators. They had no diseases, and they just multiplied. At first it was heaven. It was, they were in paradise. But as the population grew and you had density dependence, birth rates and so on, That's when the mice started acting kind of weird. And he suggested, John Calhoun suggested, that this is what is happening to the human race. Okay, there's the whole apparatus. Okay, he had them in there. Okay, so this is how he started. And yeah, let me remove this. Okay, so that was his experiment, and again, it had nothing to do with rulers imposing things on the plebes below. None of that. Okay, and this is how the experiment went. It ended. All of them ended up in extinction. He did it with mice. He did it with rats also. They all ended up in extinction. They all had the same curve where you have an exponential growth at first, then the curve, starts getting asymptotic, and then finally ends up in extinction. They stop having children. The females become aggressive. Okay, they don't mate. Sounds like the day like humans today. So you got to look at John Calhoun's experiment. You might change your mind about a lot of stuff out there. Okay, all I can say is what we're seeing today, I think, has to do with biology and not with politics. I don't think it's a question of nurture; it's a question of nature. And it's got to do again with population bottlenecks. In this case, they did not have that except one when it crashed and finally went down. But it does have to do with founder's effect. Remember, the grandfathers of these were the four couples. Okay, they were around for a while, and eventually, they created this whole population. So they all come from the same genes, and they didn't have the factor of the bottleneck factor, but they did have the density dependent factor, and that's another issue you should research if you're interested in the subject. Anyways, changing a little bit the subject, we say that humans will die not because of this, because of um, population bottlenecks or genetic diversity problems. No, it's going to be the economy that's going to. We die in a mass extinction. Mass extinction is related to the collapse of the global economy. That's what we propose here. Okay, and here's a bit of news that came out the other day. China's record unemployment has some young people seeking simpler life, and it talks about some of the problems that the youth in China have. And what it is a lot of them went to school, to college, and so on, but there are not enough jobs for them. In other words, for the new generations. And it says you had a huge expansion of university education in China over the last couple of decades, creating a surplus of youth competing for limited white collar jobs. Meanwhile, a lot of jobs that the economy is creating are blue collar jobs. Okay, so in their situation, they have um, services. The economy converted into a service economy, the Chinese economy, for the first time. More than 50% of GDP came from services instead of manufacturing. That was about a few years ago, it was around 2014, 2015, thereabouts. And today, there's more services than as far as GDP is concerned, right? As a percentage of GDP and as a percentage of labor, there's more services than manufacturing. And that number is just going to continue increasing on the service side and decreasing on the manufacturing side. It's happened to all economies in the world. It is happening to all economies on the planet. Not a single one is an exception. Okay, all of humanity is becoming service oriented and stopping manufacturing. What's the problem with that? Well, like I like to say, you're standing next to God there, in heaven, you're looking down on the planet, okay, from space. What do you see? Well, you see what is constructed, what humans have constructed. You see the tangible stuff. You see houses, you see highways, you see boats, cars, planes, you see fields of corn. That's what you see from up there. You do not see the contracts. You do not see the banking transactions. You do not see the what is it? The interest rates. None of that. None of that contracts, etc. None of that belongs to services is what you see. The promises, they're not there. And most of the work today is going into that region, into the region where it's invisible. Services are intangible. Okay, so we're putting people into the intangible world and taking them out of the tangible world, specifically from agriculture. And agriculture in the advanced nations has already almost practically disappeared. You only have 1 to 2% in most advanced nations with agriculture. About 14, 15%, maybe even up to 20% is manufacturing, and 80% is services. And every country in the world is moving in that direction. We're moving, and I call services unemployment. So if you're in the service industry, you say, "Hey, I got a job," you're not producing anything. All you're doing is exchanging money around, and that money ultimately comes down to buying the food that you need to live one more day. Okay, so it's the agriculture that's come down. We're so efficient at it that we don't need agriculture. We don't even pay attention to it because we say, hey, I want something. I'll just go to the corner store and get it. A potato or whatever you want. Not even that, because people go to fast food restaurants and it's already manufactured, packaged, and the whole works for you, right? All you have to do is have money. How did you get that money? Someone gave it to you. And so we're passing money around in the service industry eventually to buy stuff that keeps us alive one more day, which is known as food. Okay, so when the global economy collapses, in the days of the Neanderthals, Paleolithic, Cro-Magnon, everybody got their own food. You were in direct contact with food. Okay, hunter-gatherers, in those days, they caught their own stuff. Since then, we've gotten away from the only thing that keeps us alive, which is food. And today we go through intermediaries, middlemen, and they get the food for us. We don't even know how they produce it. We don't know where it comes from, how it's transported, none of that. We know nothing of that. All we know is we go to the store and magically it appears on the shelves. That's how efficient we are. And it's efficiency that's going to kill us. Okay, just to show you, here's another country. He just had an election. That's Turkey, and they voted for Mr. Erdogan again. United States is not very happy about that. Anyways, they voted for him despite, they say, this article here says, despite that Turkey is undergoing some economic problems. Okay, and it says critics blame the crisis on Erdogan's policy of keeping interest rates low. Okay, economists generally recommend raising rates to combat inflation, because one of the problems is inflation. They have skyrocketing rents. Okay, and they have problem buying basic goods. Okay, sounds like a common story that we see in every country in the world. Okay, and it says again, inflation, the fact that they say public spending is unsustainable, minimum wage problems, pension increases, etc., etc., etc. All the problems that every country in the world today has. There is no exception to this. You pick the country. You want to pick Peru, you want to pick some Uganda, you pick the country. And you'll see that it's got the same problems. We all have the same problems. Okay, and the question is whether that's going to continue or whether the global economy is going to crash. When it crashes, what do we mean by crash? It means that money will be no more. Nobody will accept money. If nobody accepts money, we're all dead, because we need money to buy food, and nobody will work for money, nobody will accept money, and nobody who produces food will accept money. So why will they produce or distribute, transport the food to you if you've got nothing to give them except some paper or some number on the internet? Okay, that's it. And so here's the trend that we can see in the last maybe 100,000, 200,000 years. We were hunter-gatherers for most of those times, those years. Maybe 10, 15, up to 20,000 years ago, maybe we started doing farming, some kind of farming. It's known as the Neolithic. And then we went into manufacturing about 300 years ago, 200, 300 years ago, industrialization. Some countries, not all countries in the world. And today we're in the service world, and we've pushed the other sectors. We're squashing them, we're muscling them aside. Okay, what is services? Unemployment, and that's on top of the formal unemployment that we have. So the question is, what's the next category? If we've already done manufacturing services, where's the next category going to come from? What is the next category? And to make things worse, within the service economy, we've moved into services, into internet services. Before we used to have some hands-on services like barbering or landscaping. Those require hands. There's services, scratching your back, that requires a service that involves touch, right, handling or whatever. Today the services are moving more, going in an abstract direction. Today's services are internet services, and there's nothing tangible there for sure. So that's the trend. Okay. How are we going to die? Well, here's an article that tells you what happened in the past. We disagree a little bit with it, in fact, quite a bit. And here it is. It says South African fossil reveal ancient beast's epic journey to oblivion. Talks about the Permian and the fact that you had these mammal-like reptiles at the end of the show, at the end of the Permian, that died. Why? Because they say volcanism happened. And that's unlike what happened in the Cretaceous, where an asteroid allegedly hit the Earth and killed the dinosaurs. Okay, so we have these catastrophes, comets and volcanism, and there's a couple more. Here's a general idea of what these people propose. They say there's climate change, there's gamma rays. These are the proposals today, the most important ones. Okay, and the question is whether any of these had anything whatsoever to do with the extinction of these animals. And here we say none of them had anything whatsoever to do with the extinction of the animals. Okay, so here's the Permian, more or less. This is what they suggest. There were explosions, especially from the volcanoes in India. Okay, and they covered the land. Essentially, that's what they're saying. And so when this spread throughout the world, it also affected a little bit the climate. Okay, and so all these factors together killed the animals. That's what they say. And the problem that all these theories have is selectivity. They cannot explain how one species died and another one survived. And that's the only issue they don't address. Or sometimes they make it even worse. They have an ad hoc mechanism for each species or for each family or for each plant, because we're not only talking about animals here. Okay, and so these were the couple of the animals, that lived towards the end of the Cretaceous, of the Permian, and they are mammal-like reptiles. You can see they look more or less like a lion and something similar to that. The difference is that these animals laid eggs. So they were not mammals. They were mammal-like. They were tigers that laid eggs. Okay, think of it that way. So they were mammal reptiles, so to speak. They had features of both. Some little animal, maybe in the wings, was the one that gave birth to humans eventually. Okay, because I'm sure that we can trace our lineage all the way to the Cambrian and before, Precambrian. Okay, some animal gave us birth, some lineage that was there in the wings, tiny animal probably, and eventually exploded and gave birth to the mammals, and from mammals came us. And others believe that it was God's magic wand. So we have these versions. Cretaceous, this is the main one, and you can see I think it's a bunch of baloney. An asteroid hits the Earth, you have all this brimstone falling on the Earth, creating all these fire tsunamis, burn the animals, I guess, and the whole planet was covered in fires. The Earth was a cinder. Okay, that's the official version. Okay, and again, the question is, if that happened, how do you explain selectivity? How do you explain that some plants survived, especially the angiosperms, right? The ones that really stayed behind were the conifers, the gymnosperms. So you got to explain that selectivity. That's what you got to explain. Otherwise, you don't have a theory of extinction. And not a single paleontologist on Earth has it. Okay, and so here you have this is what they portray. That you have all this fire coming down and stones from the explosion. They fall on the poor dinosaurs, And there you see the comet hitting the Earth. That was it, you know, or the asteroid, right? And so this is it. This is what they propose. And the issue is, they say it fell in the ocean, fell in the waters, really in the Gulf of Mexico. Okay, and another version or a parallel version, because they need to find out how to kill all the animals, right? And here's this version, which is that it created these tsunamis that flooded the land and just drowned everything out. So we have the fire version and the water version, fire water, right? Okay, so water covered the land. I guess this is like the biblical 40 nights and 40 days of Noah's Ark, more or less. That's the version. So they can't make up their mind whether the plants and animals were killed by fire or by water. And then you have the animals underneath the sea, you know, especially the reptiles. You know, here you have the mosasaur. Okay, this is what he looked like. They show him killing a shark there, but really the mosasaurs, they're apparently, from what the studies show, they were primarily hunters of ammonites. They loved ammonites. And it turns out that the ammonites ate certain types of plankton, looked like this, foraminifera, the forams. Okay, and you can see the ones from the Cretaceous compared to what followed, which were much smaller. The ones from our days were much smaller than the ones from the Cretaceous. So the ammonites ate these Cretaceous forams, and the mosasaurs ate the ammonites. So that was the chain. And it turns out all three disappear. Now that's funny. How did the asteroid do that underneath the sea? That's what you get to answer. Okay, so what do we propose here? Well, we say the same thing that happened to the dinosaurs and the same thing happened to the Permian mammal-like reptiles, the synapsids, will happen to us, and we cannot escape that same process. Here's the process. I'm going to show it for the terrestrial days of the Cretaceous. Not going to talk about water or air, okay? Just, not air and sea, but just land. And here it is. It's known as the Cretaceous Terrestrial Revolution. What happened was, from almost the first third, maybe even half of the Cretaceous, you had the angiosperms. They expanded throughout the land and muscled aside all the conifers, which is what the dinosaurs ate, specifically the cycad-like, the cycadioids, plants like the Williamsonias and so on. So they muscled aside the angiosperms, muscle aside the gymnosperms, which is what the animals ate, the ruling animals, the dinosaurs ate, and eventually the forest dried up. They didn't disappear completely. Not all gymnosperms disappeared, but it took out so much from the dinosaurs that they had trouble finding food. And so they died in a mass extinction, which is the lack of food. The ecological pyramid is what overturns. Okay, and here's what I'm talking about. Here's a graph for you can see it. Okay, the demographic pyramid of the plants overturns over time because, again, they've been around for too long. Their genetic diversity disappears. They've changed so much over the years that they can't change no more. Okay, there's not Mother Nature doesn't have any more capacity to make them change anymore, and so they reach a point where they can't expand. They can't occupy new niches. Okay. And meanwhile, you have the new plants, which in this case were the angiosperms, which are muscling them aside, which are more vibrant, which are more advanced plants. And that's what the new generation of animals that's going to take over, the mammals, are going to be eating. They expand, they radiate with the new types of plants, with the angiosperms. And the dinosaurs were stuck with the conifers, specifically the cycadioids and cycad-like plants. And those are the ones that disappear. Okay? And yeah, when they disappear, it turns out, yeah, the dinosaurs disappear. No comment necessary. It's just a regular evolution. Okay. And yeah, what you have for the animals, okay, is the overturning of the ecological pyramid, which you see at the bottom there. And it's the many chasing the few. The plants world dies under their feet, and so they're competing for ever fewer resources. And that's essentially what's going to happen to humans, and there's no way we can do anything about that. Why? Because if money is no more, and again, that's a long story to explain why we end up with no money or nobody wanting money anymore. Um, if money is no more, no one has an incentive to produce or distribute food. And we're all dependent today, on someone doing that for us. 90% of humanity, maybe, or some countries more, some countries less, but a lot of people in the world depend on, nobody grows his own food, especially in an apartment in a city. We all depend on someone else to bring the food to us, and that's the only thing that keeps us alive. And if money disappears, how are you going to get food? Well, I'll tell you how. You're going to grab a gun, go out into the country or to your neighbor, and you're going to take that food away from them. That's the way it's going to happen. So there's going to be murder, cannibalism, the whole works. And that happened, I think, at the end of the Cretaceous as well, when you had some of these T-Rexes, some of these big animals, and they started killing each other as well. I mean, when you're hungry, you eat your own kind. So get ready for it. Okay, that's what our future looks like, and it's probably going to happen quite soon. I think within my days, maybe. Certainly, anyone who's 20 years old, 30 years old, I think they're going to see the end of the world. Okay, let's move on to the number world. Okay, and we talked about numbers the other day, and it turns out that the mathematical establishment, they don't know what a number is. They haven't been able to define the word number. They don't know what a number is. Here you have two examples. I covered them the other day real quick here. Like Merriam-Webster says, number, a word, symbol, letter, or combination of symbols representing what? A number. Absolutely love that definition. What is a number? A thing that represents a number. Okay, now you know. And yeah, they confuse number with numeral. Numeral is what is the definition of that, the symbol that you use to replace or to represent a number. Okay, numeral is not number, two different things. Okay, and then you have the Wikipedia says a number is a what? Mathematical object. Mathematical object. Yeah. What is it used for? To count or to measure? I really don't know. What are they referring to? Is that like a hammer? What do they use to measure? Or count? Hammer? So yeah, we don't know what a mathematical object is. We covered that the other day, so you can look that up. Okay. So yeah, we have no idea what a number is because it's not properly defined. Okay, and when we look at mathematical object, I went over that the other day. You just get more and more runaround. That's all you get. Okay. Okay, so here we synthesize and say, what is a number? Well, according to the establishment, it's a noun. Okay, and they equate it with a numeral, with a mathematical object. Those are all nouns. And we're saying no, number is a verb. Okay? It's counting. It's a verb to count. That's what number means. Okay, you can count to infinity. That's where the word infinite came from. Okay, that means you can count forever. You never stop. Nobody's ever done that. Nobody's gone to infinity and back. Unless you went to heaven. God maybe has counted to infinity. I don't know. And so under the universal movie, we consider it a dynamic concept. So we put it at the bottom, and here it is. Number is at the bottom, not at the top. What are we talking about here? Well, we're saying that at the top you have the static concepts. Okay, like object, distance, location, existence. No motion involved. You can synthesize that in a single frame of the universal movie. For the dynamic concepts, the ones at the bottom, you need at least two frames of the movie. Okay, what is this? Means that you need at least two locations. Okay, motion is two locations or more. And a number is counting, so obviously that's a verb, and therefore it requires at least two frames of the universal movie. So number is a dynamic concept. Now, a lot of people, or a couple people, had problems with that, with defining number as counting and defining it as a dynamic concept. Here's one of them. He says the following. He says, a number is a word and a symbol representing a count, an arithmetic value used for representing the quantity. Okay, and again, when you talk about representing a count, you're confusing number with numeral. Okay, a numeral is that. Okay, so that's the issue. Number is the other words that you had there: count, quantity, amount, value. That's what number is. Number is counting. Okay, you're just putting a symbol like the number five. Okay, and that's the numeral, and that's just the symbol, and you're representing what? You're representing counting. And it's count and quantity, which is number. The representation is numeral. Okay. Okay, let's remove this one here, and we'll go with the next one. The fellow says, same fellow I think, says, one of the most important numbers is the number pi, found all through nature. And pi is 3.14. Okay, it's just a relation between circumference and diameter. But what's the problem there? You can't count to 314. You can only count to whole numbers, in other words, to integers. You can go 3, 4, 5, 6. You can't go 3 1/4, 3 5/5, or whatever, or 4/5 or whatever. You cannot count to fractions, to decimals. Okay, you can only count, whole numbers, integers, and you can't count to 0. So again, counting is what number is, and you can't count to 314. You can't count to fractions or decimals, which is simply a different form of representing a fraction. Okay, so fellow says, measuring is counting number of consistent length segments. Absolutely not. Okay, you can't count half a segment. Okay, you can only, if you're going to count segments, and that eliminates any fraction or decimal. Okay, so no, you can't count to less than 1, increments of less than 1. Okay, so here we have another fellow. He says the following. He says, technically, things like 1024 wouldn't be a number then. Why? He says, having those symbols next to each other is like period in decimals and slash in fraction. In other words, he's saying you have these symbols, 1, 0, 2, and 4, one next to each other, right? And they represent different things, he says. He says, each spot represents operations of future counting. Okay, and so he specifies there, he says, in 1024, the first tells you how many thousands to count. The second, how many hundreds, and so forth. Okay, tens and units. However, each time 1,000 or 100 is another operation to be done. And again, he doesn't understand what we're saying here. Numeral represents the number, and number is to count. So the numeral is a symbol that we use to represent to count. Okay, 1024 is a single numeral, the whole thing. Okay, you don't chop it up and say, oh, the ones over here represents thousands. We don't care about that. Okay, there's a single numeral there. Okay, and here I'll give you an example. Here you have the same number in Roman numerals. Okay, and for those of you who understand Roman numerals, there you have the M, the double C, X's, C, IV, etc. And those are Roman numerals. And you can say, well, the M represents 1,000, but see, you have two X's there, and each X represents 10. And if I wanted to represent 30, I would put 3 X's. And so now it's not positioned properly as it is in today's nomenclature. But I do an even better deal than that. There's the E with a cursive E, right? With an accent mark, and that's my version of 1024. Okay, so that's my 1024. There's no positions, no calculation, no operations to be done there. And there's the Klingon's version, a squiggly line there. Okay, that's his version of 1024. Okay, so again, you're confusing the issue here. You're thinking it's an operation and that you got to count. No, you don't have to do anything. What we're saying is we're defining the word number, and we're saying number is simply to count. You count it up to there, whether you did or not. That's what the symbol represents. It represents a number that you counted to. Okay, it's a value, an amount. I don't know if I don't think there's a single human being ever that ever counted to 1,000,000. Okay, listen to that again. Not a single human being has ever counted to 1,000,000, taken the trouble to count 1, 2, 3, 4, 5, 1,000, 1,001, 1,002, 100,001, 100,002. No one has ever done that. I'm almost sure. Unless he took a bet. Hey, I'm going to count to 1,000,000. Why would anyone do that? So when we see 1,000,000, did you count to 1,000,000? No, that's just a symbol that represent one with 6 zeros represents the value, the counting up to 1,000,000. That's all it means. So we're talking about the meaning of it. So 1,024 represents counting. It doesn't mean that you have to I have to do some kind of operation where I have to count to 1,000 to 100, and I'm going to put the thousands here and the hundreds here. No, forget about all that. It's a single value, a single numeral called 1,024. We use 4 symbols there to make one numeral irrelevant. Okay, like I'm saying, the Klingon only uses a single squiggly symbol there, and he represents 1,024 with that squiggly symbol. Okay, so no operation needed. What we're talking about is the definition of number. What does the word number mean? It means it's a verb to count. Okay, so let's get that right. And so the fellow continues. He says, I think it's the same fellow. He says, is it that you can or you have counted them? What about counting 10 to the 10 to the 10 to the 10? Can't do it? Is it not a number then? Again, we're talking about the definition, and this individual did not understand that. We're talking about the definition of number. What does the word number represent? What do we mean when we say number? And it's the verb to count. And here's an illustration of that. I showed that the other day. Let's show it one more time. This is count. Okay, it's how many times you move your finger. Okay, so we say numbers to count. And what are numbers? Many numbers. Naming each shake of the hand. So you say this is 1, this is 2 because it follows the other one. This is 3, this is 4, this is 5. We represent those symbols. We have a name for them. We say this is 5, this is 6. Those are the words we use. Okay. What are we doing? We're counting. That's what we're doing. Does it mean you had to count? No, we don't do that anymore. We don't have to do that. We can say 1,000,000 without counting to 1,000,000, and we use a symbol that is a 1 with 6 zeros to represent it. Okay, that's a story. Okay, now that leads us to what a number line is, because just now I showed you that you had many numbers there. You 1, 2, 3. When you have more than one, well, now you have a number line. Okay, and people say, what does a number line look like? What is it? And here's Bill Gates' number line. Okay, you can take this one to the bank. Okay. This is Bill Gates' number line. Here it is. Take a snapshot of it. It's going to come and go. Okay, there's Bill Gates' number line. And a lot of people don't like it. They say, Bill, I don't like your number line because it's kind of messy. Well, you go from 1 to 2, then from the 2 to the 3, 3 to the 4, 4 to the 5, to the 6, around the corner to of the 8 to the 7, then to the 8, then down to the 9. It's a number line. It's not a very straight line, but that's my number line, going from 1 to 9. Okay. Yeah, people don't like that and say, Bill, I think I can do better. Okay. And what do? Well, they have this instead. They say, this is the number line. See how neat it is? Everything is spaced out properly. We have number underneath each one, etc. This is the official, the super duper number line. Okay. That's a number line. Okay. And yeah, we have a problem here because this is quite misleading. It's misleading because it's straight. It looks like a line, the typical line. And what's not shown here is that it also has direction. Okay. And all that is misleading. Okay. That's where the problem starts, when you think that that is a number line. and you represent it with this line with a little sticks, a little arrow at the end. You say that's a number line. No, it is. Yeah, it's a number line in a sense, but it's very misleading, and I'm going to go over what is misleading about it. Okay. Here's a look up a definition, and this official site, instead of defining a number line, says it helps students visualize number sequences and illustrates strategies for counting, comparing, adding, subtracting, etc. Right? Choose number lines labeled with whole numbers, fractions, decimal, so they include everything in there, negative numbers, or use custom number line with or without tick marks and set your own interval. So they have all these variations where some of them don't have tick marks, some of them don't have the proper interval, some might have exponential tick marks and so on. They're not the same as the typical Cartesian coordinates, right? So you have all kinds of variations on the number line. We have a problem with what these people are proposing. And let me tell you why. Here it is. Here's the number line, the official version. You'll find it in the Wikipedia. And I'm saying official because anywhere else you'll find more or less the same definition. Number line in elementary mathematics, really arithmetic, right? A number line is a picture of a graduated straight line that serves as visual representation of what? The real numbers. Every point of a number line is assumed to correspond to a what? Real number. And every real number to a point. And it talks about it continuing forever in each direction. And you can see the arrow there for direction. And those numbers, integers in this case, they call them points. Okay. And you see also negative numbers. Okay. You have also the zero in there. And the question whether all of that, if any of that makes sense. Here's first what the real number is. Okay, here's a real number. Definition says real numbers include rational numbers like positive and negative integers, fractions, and irrational numbers. In other words, any number that we can think of except complex numbers is a real number. For example, 3, 0, 1.5, 3 and a half, 3 halves, square root of 5, and so on. Okay, those are all real numbers. So they include everything in the number line. Number line includes all real numbers. The problem here, the first problem, is that math has no use for objects such as point and line. They're object, why? Because they have shape. In this case, they're two-dimensional. Essentially, that's what they're illustrating. You could think of it as a 3D point, 3D line, no problem, but they're at least 2D, okay? And the point, it doesn't belong to math at all. What are you going to do? Add points? Subtract lines? What are we going to do with this nonsense? Okay, so the point and the line does not belong, neither one belongs to number line, mathematics. And then the other problems, again, is direction. And we're going to have another problem with a number line, which is orthogonality, which is, perpendicularity. And so here we have the problem is that they take time, the word time. And first of all, nobody's ever defined the word time. Okay, that's the first problem. But then they're going to say that they're going to illustrate it as a number line and call it a dimension. Okay, so this is where the problem is. Time in physics is operationally defined as what a clock reads. That's out of the Wikipedia. Okay, there you have a perfect scientific definition. What a clock reads. Okay, whatever that is. Okay, minutes, seconds, I don't know what it reads. I thought I read the clock, not the clock reads anything. Okay, and it says the operational definition of time does not address what the fundamental nature of time is. Great, we don't know what time is, but they say it's what a clock reads. They have these contradictions. They chase their tails around. But there we have an example, and what you see at the bottom is time. Okay, and it's going towards the right. You see that it's a number line because it's got all these numbers in between. It's got the partitions, little tick marks. So they illustrate it as a number line. Okay, so you can see that I think there's no doubt there. And here you have another version of that. This is known as space-time diagram, and again, they illustrate it this time upwards, okay? And they illustrate time as a number line, okay? So they call this, or they illustrate as a number line, and you see that it's got a couple problems. The one is it's orthogonal, it's perpendicular to the space number line, because that's also a number line. And it's got direction. Both of them have direction. They have these arrowheads on them pointing in a given direction. And that's where we have a problem, because number lines don't have either one of those two properties. They don't have orthogonality and they don't have direction. Okay? Those are dimensions that have those. And so we have a problem here because time is illustrated as a number line. It's treated as a number line because they're going to put numbers there, right? And they're going to separate them by seconds, minutes, hours, whatever interval they select. But they're going to call it a dimension. Okay, you see where the problem is? They're going to call this a dimension. Is a dimension the same thing as a number line? And we're going to say no, not true. Okay, so here it is. We have two sources here. First, the Wikipedia, and I like these contradictions between these two sources. A temporal dimension or time dimension is a dimension of time. I thought it was a number line, not a dimension. Time is often referred to as the fourth dimension for this reason, but that is not to imply that it is a spatial dimension. What does Stevie Hawking say? He says, in relativity, there is no real distinction between the space and time coordinates. He doesn't even call them dimensions, he calls them coordinates, okay? Just as there is no real difference between any two space coordinates. I think that's clear. So we have a contradiction between what the Wikipedia says and what good old Stevie says, okay? One guy says there's no difference. The other guy says, oh, don't confuse the time dimension with the spatial dimensions. Turns out neither one is a dimension. They're both number lines. And so the question, again, is for you to think is whether a number line is the same thing as a dimension. For instance, instead of measuring the position of a, well, he goes in there and just explains that there's no difference between these two. You can look that up later on from his book, famous book, A Brief History of Time. Okay, so here we have a problem with all these folks because we're saying, hey, you know, if time is illustrated as a number line, keep it as a number line. Don't tell me it's a dimension. And again, one of the problems these people have is they say that the universe is four-dimensional. If it's four-dimensional, it means it's got length, width, height, and who knows what else. No, they're saying it's four number lined. They have four number lines to locate any point within space-time. That's what they mean. It's the other way around. But they say space-time is four-dimensional because you need four coordinates to locate a point within space-time. That's the notion, the definition, or whatever. Okay, so here we have the difference between number line dimension for all those who care to take note. Number line belongs exclusively to math. It doesn't belong to physics at all. We don't use number lines in physics. Why? Because in physics we have to explain causes and mechanisms. Math is just a language, you know, and it's a language that uses numbers. And the number line, a series of numbers, it has no direction. As soon as they put that arrowhead, they're cheating because numbers have no direction. What they're trying to show you is that numbers increase, that's what they're counting. Remember, what is a number? A number is integers that you count. And they count them in a, you know, you can put them in any direction you want. You can count, I mean, the 2 doesn't follow physically in a given direction from 1. The 3 doesn't follow in a given direction from 2. They just say, look, we put them in a certain order so you know that numbers are increasing in that direction, but there is no direction to counting. And so the first problem is that there is no direction for number lines. The second problem, it's not orthogonal to anything. And here they put the time, especially in the space-time diagrams, they put time perpendicular to so-called space, where they put all 3 dimensions into one and they call that space, whatever that means, you know, physically. So they have the space number line, the time number line, and they put these perpendicular to each other. In what direction does time run? Forward, backward, to the sides? And does it run perpendicular to anything? Absolutely not. So number line, known as time, runs in no direction and is perpendicular to nothing. That applies to all number lines. Okay. Number line, it's counting, numbers counting, so number line has many counts because you're talking about many numbers. It's a dynamic concept. Okay, there's no static part of it. Dimension, on the other hand, it's has direction, okay, has perpendicularity, as you can see there. Height is perpendicular to width by definition, which is perpendicular to length by definition. All three of them are mutually perpendicular. Time does not fit in there because we cannot put time perpendicular to any dimension. Okay? Anyone who does that is dealing with dementia, not with dimensions. Has perpendicularity, orthogonality, yes. Perpendicular comes from perpendiculum. You do not need to know anything about angles for that. Okay. Here's this is the number line, Bill's Gately's number line. You can see I was right. We have no direction there, no perpendicularity. Okay. But here, let me show you that what perpendicular means. It comes from this. It's from perpendiculum, and that was the plumb bob, which they used to usually for walls. They would look at the horizon and say, okay, the wall is more or less straight. So you don't need to know really anything about angles to understand the concept of perpendicular. Okay, so that's all I'm trying to show here. Okay, let me get rid of this one. It's a qualitative concept. You don't need to know anything about numbers, and no need to know about angles. Again, numbers. Okay, qualitative angles. Yeah, you could say this one is perpendicular, and anything between is half perpendicular or whatever. You don't really need to know numbers to conceptualize an angle. Okay. Now, if you want to tell someone, look, it's a 30-degree angle, yeah, then you're going to have to put a number in there. Okay. But then we don't need numbers to understand angles. It's just a qualitative, two sticks. That's all it is. Okay. Without knowing the language of someone else, here I'll take two pencils and do it. You can say, look, this is more or less what the angle was that I saw of whatever. And you don't even need to know much of the language or what the angle exactly was. You say it was more or less like that. And the guy understands, okay, I know what you're talking about. Neither one needs to know how many degrees that thing was turned over, which is what degrees are. It's how much you uh, scan one stick with respect to another. No magnitudes involved, and it's a static concept. Dimension is a static concept. So yeah, these two are very different. One is dynamic, one is static. The other one has direction, the other one doesn't. And one has magnitude, and the other one doesn't. One has perpendicularity, and the other one does not. Okay, so here we have good old Hawking, and he says that's why he ends up saying the nonsense that he says in his book. He says it is often helpful to think of the four coordinates. Oh, coordinates! I thought it was a dimension. Okay, or a number line or whatever of an event as specifying its position in a four-dimensional space called space-time. It is impossible to imagine a four-dimensional space. Yeah, no kidding. But yeah, so he's saying that it's four-dimensional. No, or four coordinates. It's neither one. It's four number lined. That's what they're talking about. They're not talking about dimensions or coordinates. What the problem is that they define a dimension as the number of coordinates. And what is a coordinate? A number, so it's the number of numbers. They're talking about number lines. They're not talking about dimensions. And so to say that the universe or space-time or whatever is four-dimensional, it's a lie. Okay, it's a lie from every point of view, from a definitional point of view and from a physics point of view. No such thing as four-dimensionality, no such thing as a universe that is four-dimensional. Okay? In fact, the universe is not even three-dimensional because when they use the word universe, they're talking about space, and space has no dimensions whatsoever. Space is zero-dimensional because it's nothing. Only things have dimensions, and space is the opposite of thing. It's a nothing. Okay, and so here we have it. It's a static concept for, it's a dynamic concept for number line also. Okay, number and number line both are dynamic concepts. Okay, neither one is a static concept. Okay, so in the universal movie, you need at least 2 frames of the movie to conceptualize a number line. Okay, let's get on with some of the questions people had comments. Here's the first one. Paul says, what is sound? Have you given lectures on sound? I don't. I've covered it. Not specifically, but sound is what sound is. Is compression, rarefaction of here on Earth, right? Of air, atoms of air, molecules of air. Um, they just vibrate back and forth, and that's why you can hear them, because we've through evolution we've adjusted our ears to accept those vibrations and understand different tonalities, different um, vibrations of these atoms and molecules that are banging against our eardrums. So it's no mystery. I mean, we don't have a problem with that here, at least in rational science. No difference whatsoever with the establishment on that. Okay. Here we have another fellow says, physical connections to physical connections atom to all other atoms is physically impossible. What we have observed of the universe so far amounts to an accurate estimate of 10 to the 82nd power of atoms. Lots of atoms. That's only in the observable universe, okay, what we can see. If the universe is, or what we can calculate, remember these calculations are, very ballpark. If the universe is infinite, okay, now listen to this, it would just completely saturate out with physical connections. Well, if it's infinite, it wouldn't saturate anything. But he doesn't understand that. He contradicts himself. I mean, if it's infinite, meaning it never ends, right, then there is no problem with space. Okay, you have all the space you want. At the size of the known universe, the observed universe, right, 10 to the 67,000 power physical connections would be required. Right. Okay, so he calculated with these I'm sure he didn't count all that like the other guy said, right? Okay, that would be analogous to trying, I guess, to put 1 billion fish in a tank with a capacity for 5 fish. Not enough space. Well, again, if your space is infinite, you have no problem with space. It's a done deal. No problem there. The other problem is he's talking about fish, which is like atoms, not about the connections between fish, which is the connection between atoms, which is what he was challenging. So he doesn't even understand that one. So he made so many errors that, just in one paragraph or whatever that, 3 sentences, 4 sentences, that's, well, what can we say? No, we don't have no problems. Hopefully there are gazillions of atoms in the universe, okay? Every star has gazillions of atoms and there are gazillions of stars, so forget about counting that. There are countless atoms. We'll never count them. And all we're saying is between any atom that exists, there's a rope that interconnects them. They're physically connected. There's an interconnection, physical interconnection. We're done, So if there are so many atoms, there are so many ropes. And so we can tolerate for many atoms, there should be no problem tolerating it for ropes. No, so his argument is totally worthless. Okay, here we have another fellow, and he says the following. He says, Einstein said velocity of light multiplies mass. And yeah, and he says, you can't tell that to a normal thinking person. Even funnier is no one has found that hilarious in over 100 years. Absolutely. So to say that velocity multiplies mass, what does that mean? Okay. Unless you find physical meaning to that equation. It's a calculation, right? If you can find physical meaning, then you're doing physics. But just to say that velocity of light multiplies mass, so we have what, seconds squared, meters per second squared times kilograms. What does that mean? So he's right, it makes no sense and people should be laughing at that. With that, I'll see you next week.